Hello, and welcome to today's web seminar, Practical Tips and Tricks for Selenium Test Automation, sponsored by Sauce Labs and featuring Selenium expert Dave Haeffner. I'm your host and moderator, Beth Romanek. Thanks for joining us today. Before I hand it off to the speaker, let me explain the controls on this console. The console opens with 3 panels. All of these can be moved around and resized to your liking. At the bottom is a widget toolbar. Hover your cursor over the icons to see labels identifying each one. Through the Additional Resources widget, you can download a PDF of the speaker's slides and more information and resources from Sauce Labs. If you experience any technical issues, please send a note through the question field beneath the panels, and we'll be on hand to help. Our responses can be read in the Q&A panel to the left of the slides. This is also how you submit questions. Feel free to ask questions throughout the presentation, and we'll answer as many as possible during the Q&A session at the end. Finally, to optimize your bandwidth for the best viewing experience possible, please close any unnecessary applications you have running in the background. This event is being recorded and will be made available for on-demand viewing. Once the recording is ready, you'll receive an email with instructions about how to access the presentation and slides on demand. And with that, I'd like to hand it over to our speaker, Dave.
Oh, that's for me. Hi everybody. How's it going? Can you still hear me right there?
Sound great.
Great, cool. All right, so thanks everybody. So next slide. So this is Selenium tips and tricks. So if you're new to Selenium, I just wanted to say that this talk is probably not the best talk for you. However, I do have some resources available. I actually offer a bunch of free stuff. So I have a Selenium bootcamp at this link, and I actually have these slides are chock full of links. And so this link, every link will have a bit.ly, it's a short link. So go ahead and check out everything I talk about, and the slides will also be available after if you miss these links. So I have a Selenium bootcamp, and it's a 5-part email course which covers how to get started with Selenium. And so it covers both Ruby and Java, so a scripting language and a compiled language, depending on where you are and which preference you have. I also have a book I wrote which covers everything on how to get started with Selenium. And then I have a weekly tip newsletter that I send out every Tuesday on tips on how to use Selenium like a professional. And that's actually kind of the basis for this whole talk. So this is the newsletter. It's called Elemental Selenium. And it is kind of the main passion of mine. It's something that I really put a lot of effort into to make sure that everyone has really useful tips every week. And so I've taken about 10 or 12 different tips that have been really well received to cover more advanced topics. And that's what this whole talk is kind of based around. And so most of the tips I'm going to talk through cover Ruby, so and some of them are in Java, but basically the point in me mentioning this is that even if you're not proficient in Ruby, Ruby is actually a very English-like programming language. So it should actually conceptually make sense, and you should be able to follow along regardless of your background and technical expertise. And all the examples built in this tip newsletter are built against this open source application that I built called the Internet. And the Internet is an open source web app that mimics behavior and functionality that you find on the web. There's almost 50 different examples on this web app now, but very common stuff like logging in, basic auth, a page with broken images, really challenging constructed pages. Just the list goes on and on and on. So I put this link if you're interested in kind of checking it out on your own. And so the first kind of section of tips I want to cover is actually a very popular one called headless testing. It's the concept of running tests without, on a computer without a monitor, or potentially running tests without a browser, technically speaking. At least a browser you can't see. And so the benefits of headless testing, it's typically faster, depending on how you have it set up. And ideally it's less maintenance. Depending on, because usually running headless tests involves a smaller footprint. And then you also, even though you're not running with a browser potentially or with a monitor, you still get the benefit of being able to capture screenshots. So if there's an issue, you can actually still see what's going wrong. And so one of the most common ones that people end up using, it's kind of the entryway into doing headless testing, is to use something called XVFB. And for each of these tips, I have a corresponding link that will take you to the tip, which has a more in-depth write-up about everything I'm talking about. And so XVFB is short for X virtual frame buffer. One sec. There's the build-in. It's basically an in-memory display server. It's predominantly only for Unix-like systems. So Linux would be the most common place you're going to see this. And what it enables you to do is run graphical applications without having a monitor or some kind of display. So basically, the most common use case is running a browser on a continuous integration server that's running on Linux, which is actually a very common configuration. And you also have the ability to take screenshots, like I mentioned. And so why use it? Well, it's ideal for running small test suites on a headless machine. So if you're just getting started with automated testing with Selenium, and you want to have some automated feedback loop on your continuous integration server, and you only care about like one, maybe two browsers, very quick and easy to set up, and then it's fairly straightforward to maintain. Okay, so there's two different options for setting this up. The first option is the manual way to set it up, and to do that, if you're on your Linux machine and you have installed XVFB, you would start up the program and then background the process. And when you start it up, you have to specify a display port, and then of course you have to tell the system which display port you've used, and you do that in the terminal session. And then you can run your tests. And when you run your test, it'll open the browser, and it will open the browser in the virtual display port that you specified. The thing to remember with this is that when you do this setup, the XVFB session is going to keep running in the background until you actually manually stop it. And there's also a couple other things. There's the potential for running into display port collisions. If you actually run the same process twice, and both times you specify the same display port, you'll run into issues. So there's two different ways to handle that. You can specify a unique value when you launch XVFB. An example of a unique value could be the build number in Jenkins or whatever continuous integration server you're using. Alternatively, there's actually a command line flag that you can specify. I believe it's -A, and then that will make XVFB find a dynamic port that's available for you so that you could avoid collisions. A cleaner approach is potentially using the binary that comes with XVFB called XVFB-run. And when you actually prepend this in front of a incantation for running your test, it will handle starting and stopping XVFB for you, and then you won't have to worry about display port collision. And of course, there's a third option, especially if you're using Ruby, the Ruby programming language. There's a library, a gem called Headless. And what you have to do is update your test code and the setup and teardown that's responsible for giving you the browser and destroying the browser, and have it use XVFB. So the library just gives you simple API hooks to do that. And what that would look like is this. Here's a simple test in Ruby using RSpec with Selenium to give you an instance of Firefox while also using the Headless gem. And so in the setup and teardown here, there's a Headless .new and a Headless.start, and that's what's responsible for starting up the XVFB session. And then in the teardown, there's a destroy action as well. And a more common approach and more popular, especially as you maybe feel like you've outgrown XVFB or it's just not giving you what you need, is a solution called GhostDriver. And GhostDriver is actually the Selenium bindings for PhantomJS. And PhantomJS is a headless browser that gives you the full web stack. Basically what that means is it gives you JavaScript rendering, whereas a lot of other headless browsers don't do that. So that's the biggest advantage for PhantomJS. And also PhantomJS is fast. It's basically, it doesn't require the startup time of a full browser, but it gives you a lot of the same functionality of it. And so thanks to GhostDriver, this is actually bundled into PhantomJS. So if you have PhantomJS, you have GhostDriver. And then you have to only make a small tweak to your Selenium test to be able to take advantage of it. And so why use it? It is faster, as I mentioned, and it's also useful for it. CI server. So you could very easily swap this out for XCFB, get faster execution times, and then you're actually not running it. You wouldn't be running it for Firefox or any of these browsers. You're actually getting something that's a little bit beneath that. It's like the same thing that a lot of using the same rendering engine as some of the browsers. So you're effectively kind of getting the same behavior as a browser, but you're not truly using those browsers. And it's also, the advantage is it's not limited to just Linux. So if you're actually not running a CI server on Linux and you're running it on Windows, then this is a better option for you. And an example of what this looks like, the steps are you have to download PhantomJS, and then you start it. And when you launch PhantomJS, you have to specify a WebDriver flag. And to do that, you just specify --WebDriver and then the port number that you want to use. And in this example, I've just specified port 8001. And then you have to connect your Selenium test to PhantomJS. And the way to do that is the same way that you would connect to an instance of Selenium Grid using Selenium Remote. And then if you actually wanted to, you could connect PhantomJS instances to a Selenium Grid. And I have a write-up on, actually, this is a link to the documentation that covers how to do that. And in test code, this is what this looks like. It's a very simple, again, another Ruby RSpec test. The thing to point out here is the line in setup, the driver incantation, where it says Selenium WebDriver for remote. And then it specifies the URL. That URL is the localhost and the port for PhantomJS. So if I were to run this test, it would actually open an instance of the browser with PhantomJS and run the test and do the assertion. So changing gears, I want to talk a little bit about visual testing and what visual testing is. And so just to give you a quick primer, visual testing is the ability to check an application's interface, make sure it appears correctly to its users. This is something that's often been thought to only be doable manually. But the goal of it is to find visual bugs before your users do. And some visual bugs like font being broken or the layout being completely off, having any sort of rendering issues, any sort of visual defects in your page. And the cool thing is it's actually something you can use to verify content. Whereas with traditional automated tests, you'd actually have to copy and paste words to compare. Instead, you can actually use visual testing to say, nope, this looks the same because the content is the same. And then there's bigger things, not just content, but charts, dashboards, things that's very dynamic with dynamic layout that displays data to a user. But really the big important thing, and why I think it's interesting and why I'm talking about it, is that you effectively can get hundreds of assertions for just a few lines of code. Because when a visual check is being performed, it's checking hundreds of different components of a page. Whereas when you're doing an assertion for a single Selenium test, normally you're just checking 1 to 2 elements on the page. This is checking the entire page. And the cool thing is that there are at least 16 open source solutions that I know of that are available to choose from to get started with automated visual testing. And a lot of them actually work with Selenium. So you can actually incorporate automated visual testing into your existing Selenium test. So the creator of Selenium always told me that you really shouldn't recommend a piece of technology unless you can mention at least 2 bad things about it. And so the first one is that visual testing, since it's an automated thing, there is complexity that you have to manage. Because normally with automated web testing and mobile testing, you have to deal with the complexity of different devices and browsers and operating systems. And so you have all of that complexity with automated visual testing, plus additional things to consider, viewport size, anti-aliasing, and the list goes on. And the permutations become very challenging very quickly, but it beats doing it with automation definitely beats doing it manually and manage the complexity. And then the next one is, of course, false positives. This is doing visual testing with automation is a fairly sophisticated thing, and it's very easy to have your software trip up with false positives. Things like when content shifts just a little bit, or if there's a page with the layout it's always the same, but the content on the page is dynamic, it's changing, or even something as simple as typos. There's some automated visual testing solutions that miss typos, which isn't that great if you're trying to verify content. So, but there is a pretty solid one-two punch that I found, where you're able to get access to challenging browser and devices, as well as mitigate a lot of false positives and be able to just get up and running really quickly. Using a platform like Sauce Labs, you can get access to every browser, operating system, and device that you would ever potentially care about, and it's turnkey. It's very simple. And then something like AppleTools Eyes. These are platforms that both work with Selenium WebDriver that also have free trial accounts. So you could very quickly kick the tires, do a proof of concept, and see if it's valuable and works for you or not. I use it in my own testing practice, and it works for me. And so I want to talk a little bit about how I've used it and just a quick example of that. So this is a Java JUnit test, a really simple test that just gives a Firefox instance, logs into a page, and then makes sure that it was able to successfully log in. That's all it's doing. It's very simple. So if we wanted to take this test and actually add in visual testing with AppleTools Eyes, here's how we do it. So in the setup, what we do is we're still creating an instance of Firefox. But what we've done is we've actually imported the AppleTools Eyes library, the class, that gives us access to the API. And what we've done is we've set our API key. And in this example, I'm doing it with an environment variable, but you can do it with a hard-coded string if you wanted to. And then we're actually taking and creating an instance of AppleTools Eyes, which returns us a modified Selenium WebDriver object. So what happens then is every command gets executed through, just like before, but it runs through AppleTools Eyes, so we're able to capture a screenshot when we want to. And then when we're doing that, we're also specifying the name of the application and the name of the test so that we have helpful information in the dashboard. And then we just add a couple of bits to our test and our teardown. We actually can choose where we want to take screenshots. So we do that by saying eyes.checkWindow, and then we can pass in some information as a string. So in this case, I'm checking right before I log in, and then I'm also checking, grabbing an image right after logging in. And then at the end of the test, I call eyes.close, and then that will perform the final check. It'll actually compare all the images that we just took against baseline images. And then in the teardown, we want to make sure that we're aborting the session if it wasn't closed properly. So if for some reason it never reached eyes.close, we can still clean up the test. And so the way that visual testing is going to work is you have to run the test, it captures these images, and then AppleTools Eyes will provide you with a link. And then you have to go to the dashboard and then approve or reject the images as the baseline. And then every future test run will compare the images it grabs with the images that it already has stored. And then it will perform its algorithms to make sure to see if there's any sort of significant visual anomalies. And so when you run the test, it looks like this. This is just the IntelliJ output. But in the bottom right where it says cdetails, that's where it has the URL. And then that URL would take you to the dashboard, which looks like this. And in the dashboard, it found a significant visual anomaly, something that was missing, and compared to the baseline. Like it was here, and now it's not. And then in this dashboard, there's a whole bunch of other things. But with this visual anomaly, you can choose to approve or reject. And I reject this because this is a visual anomaly and save it. So then if I run the test again, it would still see the same issue. And then, so this is basically something simple, a really rudimentary example of, hey, I logged in, and now there's a log out button that's not there. And then if we wanted to take this test and take it one step further and say, we figured this out in Firefox, but what about like Internet Explorer? So this is how we would wire up something like Sauce Labs. And the setup for this is there's a couple things to note. This is a very nearly identical configuration to how you would connect to a Selenium grid if you're actually maintaining your own Selenium grid. So it's very easy to point at Sauce Labs and get access to their fully furnished infrastructure. So basically, you have to have a desired capabilities object, and then this is how Selenium Remote knows which browser and operating system to connect to when you're connecting to a grid. So in this case, we're setting this to set capabilities, and store them in a desired capabilities object. So we have to set the browser version, the browser type, the platform we want, and then we can actually also specify the name of the test. And then we have to, of course, provide our credentials to access Sauce Labs, which is behind basic auth and pointing at their on-demand URI. And then after that, we, instead of just saying, like we were doing before, we're like browser for Firefox, we're actually using a remote WebDriver. And when we do that, we have to pass in the URL to get to the endpoint. And then after that, it's the same setup as what we were doing with Apple Tools I. And that's pretty much it. That's the only complexity, aside from signing up for these accounts, that you need to handle in order to get access to, in this example, Internet Explorer 8, which traditionally would be a pain in the butt to stand up and maintain. And then once you run your test, this is what a job dashboard would look like. Although there is, I believe, a new beta dashboard that's coming out that will look even sleeker than this. But it has a screencast, so it actually has a video of the test as it was running, has screenshots and all the commands that were issued. It has all of the log from the Selenium server as it was running, and also all the metadata that you passed into the test when it was run. So it's ideally enough to find a smoking gun if there's a test failure. Because a lot of times, as you may or may not know, is when there's a test failure and you have all this information, like that's the most important thing, because you could run the test the second time and not get the same result. The transient test failures are very, very common and very frustrating, and a surefire thing to start to erode your automated testing practice. So as much information as possible in a turnkey way is pretty stellar. I've actually written quite a bit about visual testing over the last 6 months, so I don't expect you to read all of it, but I'll give you these posts anyway, just in case you do get interested. So there's a Getting Started post, which outlines all of the different open source solutions for visual testing. And then I actually cover a lot of the common false positives that you run into and some ways to potentially mitigate them. And the first few posts I actually cover other open source solutions as well as applicable guides. And then there's a post on how to add visual testing to your existing tests. And also, if you're interested in behavior-driven development, something like Cucumber, then I also wrote about that there. If you only read one post, it would either be the first post or this fourth post. I think that those are probably the most important ones to get started with, just in terms of kind of wrapping your head around visual testing and the benefits and pros and cons of it. And I'd be remiss if I didn't also mention some resources for Selenium Grid, because you could very well incorporate visual testing with a Selenium Grid. So there's these three write-ups where I cover Sauce Labs integration as well as Selenium Grid, and then an extra library called Selenium Grid Extras, which is a library written by one of the core maintainers of the Selenium project, Dima Kovalenko. So he did a guest post on my newsletter where he stepped through what his Selenium Grid Extras library does. It basically makes it easier to maintain Selenium Grid and capture videos as well. So worth a read if you're interested in going that route, or for some reason aren't able to go the route of Sauce Labs. Okay, changing gears once again. I want to talk about proxy servers. And so there's a series of tips that involve proxy servers. And the reason why a proxy server is interesting is it enables you to do things with Selenium that you can't do with just Selenium. Things that potentially you used to be able to do, like grab HTTP status codes and things like that. Like you just can't do that anymore with Selenium just by itself, because Selenium is built to mimic human action, and getting access to these lower things within the browser stack is just not something that you're able to do. So we use a proxy server, and what that looks like is we have a box without text. So basically, we have our Selenium test. There it goes. And then we have the browser, and then the proxy server, and the application on your test. And so basically, you have your test that has Selenium commands, and you configure it to use a browser. And between that, between the Selenium, the browser, and your application, you set up a proxy server. And so basically, you connect Selenium with the browser through the proxy server. So you're able to actually capture and modify each action that's going to the application before it gets there, and even same on the response back. And so for something you would want to use a proxy server. There's numerous ones, but the most common one you're going to see thrown around is in the Selenium community is browser mob proxy, and it's it's open source, and basically it is a simple proxy server that you stand up, and then it has its own little REST endpoint that you can send commands to. And each, I think there's bindings for each, for a few different programming languages. So in Ruby, there's actually a library to make it very easy to interface with the proxy server. And so the most common ask from a lot of people in automated testing is, how do I actually grab the status codes? Like if there's if this page returns a bad status code, how will I know? I'll just want to preface this tip with, Selenium is really not the right tool for the job, but we can make it do it, and this is how you do that. And the configuration. So as I mentioned, you use the proxy server and you capture the traffic. Your tests run, you can grab the traffic and then see what you see. And then what you can actually do is find the status code of the specific action that you're interested in. So say if you visit a URL and you want to know if the URL returned a 404 or 301, or you actually want to just see if it returned a 200 status code. You can then assert that the code is what you expect. It's pretty straightforward. So the way to do that is once you download browser mob proxy, you can set up a simple test like we're doing here. You have to, with this browser mob proxy library, specify where the binary file is, and that basically will create a server instance. And then, okay, here we go. And then you have to configure a profile. So the only way that you can use Selenium with a browser and maybe connect through a proxy server is the same way you would do it manually if you're standing up a proxy server for your browser just to test it by yourself. You have to go into a profile and then specify the proxy server value. And so we can do that by creating a profile object. And in this example, I'm using Firefox and a Firefox profile. And then after that, we have to create an instance of Selenium and then pass in the profile. And then that gives us Firefox with that configured profile. And then the next thing we have to do is actually use the proxy server to capture the traffic. And so that's what this would look like here. What we're doing is capturing the HTTP archive. It's also known as the HAR, the HAR. And so in this method here called retrieve status code, I am capturing a new HAR and then receiving a block with the yield command, and then returning the first status code that I get. And so the way I'm using it is in this run block, this test. I'm basically just visiting a status code page. And the status code page is designed to return a status code for the number you give it. So if you go to status code /404, it should return a 404. And so what I'm actually doing here is I'm using the retrieve status code, passing in the Selenium command, and it's going to run it, capture the HAR, and then return the status code from it. And so once we get that status code, we can assert that it actually was what we thought it should be. Another common way to use proxy server with your test is to do blacklisting. Finding third-party content that could potentially take a long time to load or kind of muck up your test. You can actually find it and force it to not load. And the way to do that is with blacklisting. And so what that looks like is you use the proxy server not just to capture traffic, but to actually manipulate it. And so you would identify third-party resources that are slow, or whatever, just third-party resources in general that can negatively impact your test. And then you would use the blacklist command. And to do that, you actually have to use regular expression to find the thing you want and then change what it does. And it looks like this. This is actually nearly identical to the last test we just did, with the exception of the second line in the setup, where it says proxy.blacklist. And so what we're doing is on this page, this example that I have called slow external. Slow external has a resource on it that takes at least 30 seconds to load. And what I'm doing here is I'm finding it, and then I'm specifying what status code I want it to return as. So basically, I'm forcing it not to load by making it just return a 404 instead of even trying to load. Effectively blacklisting it. I could have made it whatever status code I want, but 404 seems appropriate. And then what we do here is, this is the test in the run block. We're doing just like very similar to before. We're capturing a new har. The only difference is that we're actually we're just grabbing out a single entry that whichever one includes the flow external, and then making sure that it was set to 404. Because if we ran this and didn't do the blacklisting, then the flow external would just continue to try and load and wouldn't necessarily have a set of code. And this is one of my more favorite ways to use a proxy server, probably a less conventional way to use a proxy server, but it's to set yourself up for load testing. And what that looks like, you would use the proxy server to capture traffic. And then you could convert the har, the HTTP archive, into a JMeter JMX file. So this doesn't give you like a fully furnished load testing suite, but basically you could take existing user behavior that you have captured in your Selenium tests and then convert them into JMeter load tests, effectively, at least the initial basis for modifying them. So it saves you a bunch of work, basically. And then you could just run the JMX file with JMeter to enact a load on your application, and then tweak the test as you need. Add in parameters and the ability to data drive your load tests and that kind of stuff. And what that looks like is setting up a proxy server, just like before, and capturing the traffic just like before. And then, so all that's very much the same. The thing that's different is that we're saving the har file. We're saving the har to a file. So there's like a .save to command that we're using. And then there's a converter that we can use to take that file and then output it as a JMeter JMX file. And it looks something like this, which don't worry too much about this code specifically. This is actually adapted from an existing library called Ruby JMeter, which was written by a company called Flood.io. And they offer a JMeter in the cloud solution very similar to other providers that exist. And so basically, I took this code and modified it for my needs. And what it basically does is it takes the HTTP archive file, which if we open it in a browser would look something like this. It actually lists every single command, every transaction that was occurring within the page request, and instead converts it so it looks like this. It ends up becoming a JMeter JMX file, and so then you could take this and run it in the next load and, like I said, modify it. So you could take like the most complicated Selenium script and run it through this converter, and you'd end up with like basically a JMeter JMX file you can use to enact load. So you can do this over and over again and create basically a suite of JMeter files. Okay, let's move on. One more fun use of a proxy server, as well as some other ways to do this. But if you have broken images on a page, how could you check them using your existing Selenium bag of tricks? The obvious one would be visual testing could catch these. But if you're not doing visual testing and you want some ways to detect broken images, there are 3 different ways to do it outside of visual testing. You can actually use a proxy server. You could use a third-party HTTP library, or you could use JavaScript. The first one involves proxy server. Like I mentioned, same setup as last time. The difference is that once we get to the page that potentially has broken images, and there's an example on the internet that has broken images, what we can do is use Selenium to get all of the images on the page, all of the source source tags from images on the page. And then we can iterate, yeah, that's right. Then we can iterate through all of the images and find which ones actually have a response status of 404, which means they're broken. They just didn't load correctly. And then we'll store that, all the ones we find, into a collection of broken images. And then we can and then what we can do is assert that the collection is empty. If it's not empty, then we have broken images. And then if we wanted to, we can actually ask what they were and what the URLs were. Alternatively, we can use an HTTP library, which is a pretty good approach. I think it's one step better than using a proxy server because it's not as heavy. But basically, we can use something like REST client. There's numerous ones in Ruby. Every programming language has a good HTTP library. It has numerous ones. In Ruby, REST client's a pretty good one. And what we can do is, just like before, we go to the page with Selenium, and then we grab all the images. And then what we can do is use REST client to get the URL for each image, and then check the status code, because an HTTP library gives us access to status code out of the box. And this is much faster. And then the third option is JavaScript. And the difference here is that we're basically executing JavaScript. And just like the first example, we're storing a collection of any broken image that we find. The way that we're using JavaScript to do this is that we're actually checking to see if the image has a correct width or is set, or if the width is set to undefined. And if not, then we can capture this was a broken image. Of all the different options, I think this third one's the best, just because it doesn't require any additional libraries to do it. The only trick is that you're using JavaScript. But if you don't know what this is doing, then I'd say one of the other options might be better suited for you. Just depends on your level of comfort. So stepping outside of the proxy server conversation, let's talk about forgot password real quick. So a lot of times you might want to test forgot password for a system where you type in an email address, and then it emails you forgot password link to reset your password. And if you wanted to test this end-to-end, this could be really challenging. But there's one way to potentially go about it. You can use Selenium actually to trigger the forgot password workflow. Like open up a browser, click the link, and if you send it to something like a Gmail account, you can basically have the Selenium session stay active and just stay idle off to the side. And then once that's happening, you could use an API to potentially retrieve the information out of an email account. So if it's Gmail, for example, there's a Gmail API. So you don't have to write a Selenium test to go through someone else's front end, which could constantly change. But an API will be fairly stable and a lot faster, so you could do something like that. And then basically you can use the API, grab the forgot password email, pull the information out, and then put it to use in that idle Selenium session that's still active. And so here's an example of doing that within Ruby. There's a gem in Ruby called Gmail, which makes it super easy to connect to the Gmail API and interface with it. The only trick about all of this is latency, or rather delay. The delay from when you trigger forgot password email and when it actually shows up in a third-party email provider's inbox. And also whether or not there's any sort of downtime issues. But for the most part, it's pretty good. So what you want to do is build in an intelligent retry mechanism. And in this method that says try number of times down at the bottom, that's what I've done here. I basically made it so that it will intelligently retry checking the email for a predefined amount of time, which is configurable, until the email in question shows up. And if it doesn't show up within a reasonable amount of time, and it can be set to whatever you want, but say minute, then it will fail. But for the most part, it'll keep trying until it finds what it needs. And then, and then the test. And so what the test does, on the internet there's a forgot password piece of functionality which sends an email. So you put in your email, hit click to submit the form, and then the next step is you want to find a forgot password email from Gmail. And so we connect to Gmail using an email username and an email password, which are stored in environment variables. And then we're using the intelligent retry mechanism to try 6 times. So it's once every, in this example, once every 10 seconds it's going to check. So for a minute, it's going to keep trying. And what it's doing is it's checking the inbox for any unread emails from the email address that this example is sending from, which is no reply at the internet. And it's going to find the most recent one that it finds. And then it's going to grab the raw source of the email message body, and then it's going to pull, and in this case, is just a URL to a URL for the forgot password reset, and then a username and a password to use. And so basically, we can regex through the email, grab the username value, grab the password values, and then put them to use in Selenium, which would then get this URL we just pulled out, and then plug in the username and the password, and then submit the form. And then the way that we make sure that it was successful is that we can see if it ended up taking us to a secure site. And so that's one way to test. Another example, a common, potentially challenging thing that could trip tests up. I mean, forgot password is hard end-to-end to test. A/B testing can also be really challenging to deal with in your automated tests. So A/B testing, this is also known as split testing, and it's a simple way to experiment with different forms of a page. Typically, features on an application, and you want to see which features could lead to higher engagement from your users. And so basically, a simple thing would be to test variations of a single feature, like an email landing page, for example, to see if more people sign up. And in split tests like this, there would be a control, and that's the control is how the application normally looks and behaves right now. And then you'd have variants, like 2 or 3 different changes that you or the business or whoever wants to test out to see if they'll could change, lift the engagement. And things you might change would be like text on the page, element positioning, changing elements in general, color of a submit button, things like that. And then once those variants are configured, they're put into rotation, which means that once this experiment starts, each visitor will get a different variant of the page. And so that can wreak havoc on your automated tests if you're getting inconsistent elements on a page. And so these tests generally run for a predefined length of time until a winner, or quotes, is found, typically based on if there's a lift in engagement. And then if there's no winner found, these new variants get introduced and the experiment gets rerun. So rather than kind of deal with this tap dance of someone else changed the page and now your tests break because of things outside of your control, you could opt out of it. And so a very common platform used for A/B testing is Optimizely. Optimizely is a software as a service platform that makes it fairly straightforward to set up split testing. A lot of companies use it. And within their framework, it's very easy to opt out of A/B tests. So if you end up knowing that the way the page normally should behave, without any sort of variations from the business, et cetera, whatever the control is effectively, you can opt out of all of that and just test the page as it was designed initially. And so what that looks like is something like this. There's, in this example on the internet, there are 3 page states available. You can identify which state you're in because the header text will change. And so in the control, the text will say A/B test control. Variation, there's one of them. They'll say A/B test variation 1. And then if you're not in a test, they'll just say no A/B test. So the way that gets configured is you could forge a cookie. This is with an Optimizely. I mean, most of the platform providers for A/B testing have similar features, or if you have something custom in your organization, then you might have something different. But for the most part, you can forge a cookie or append a query to the URL. And then this will help get you a known state of the page. So that way, things aren't going to change without you knowing. So what that looks like in test is this. Here's a simple setup and teardown for getting a browser using our stack and Selenium. So you get Firefox, and then in this test, we'll load the A/B test page. And then before we actually do really anything fancy, we can grab the header text, and then what we're expecting it to be is either the A/B test variation 1 or the control. And then after that, we add a cookie. And in this case, the cookie is Optimizely opt out and set the value to true. And then refresh the page, and then grab the text again and make sure that it actually put us into the no A/B test, which means that it took us out of the test. So if you're running Optimizely and you wanted to kick the tires and see if this works for you, this is a way to verify that that actually works before incorporating into your existing test infrastructure. An alternative way to do this would be just go to the homepage of your application, add a cookie, and then go to the page, and you should also still not be in the test. And then there's the third option, which is just specifying in the URI, saying Optimizely opt out true. it'll pop up a JavaScript alert, which you can dismiss, and then you should go to the page, and it should be fine. Okay. Kind of getting into the home stretch here. So I'll talk briefly about file management, because this is something that comes up a lot for people that aren't familiar with it. When you're uploading a file, a lot of times you'll end up seeing something like this, a simple form where it says choose a file, click upload. And this is where you start to see the themes of Selenium, like where things start to become outside of its realm of control. Because when you click choose file, it pops up a system dialog like this. And Selenium can't interact with that. And so a lot of people might reach for something like a robot, a Java robot library, or AutoIT, or something that enables them to interact with those things. But that can be a long-term challenge for you if you do that, because then that solution may only work in Windows. So if you wanted to test this, you really only get it in one platform. Or you could potentially do something else. There's a workaround that helps you sidestep needing to even trigger the system dialog pop-up. And so what that would look like is this. You can send the file path. So if you actually know the path of the file, you can actually inject it into the form field and then submit the form, which would not need you to pop up that dialog at all. And so what that looks like in a simple test is this. So say we have some file.txt, and we want to get the, I specify the file name, I grab the entire absolute path of the file. And then I load this upload page, and then the important part here is the fourth command, the send keys command, where it's finding the file upload field and then inputting text into it, and it's inputting the absolute path to the file. And then you click to submit the form, and then afterwards the page will display text of the file that just got uploaded, and then you can basically just assert that is what you expected. The important point to mention here is that if you're actually going to be doing upload tests on a remote node using Selenium Grid or Soft Labs, you want to make sure to look at the Selenium file detector. This basically takes the file and then makes it so that it passes it over the internet to the node to make sure that the node that's running the test has access to that file. And so that's just an important point that you're going to want to think about, because that will trip up your test, and it might not be obvious as to why it's failing. Downloading files is a bit more interesting, because there are numerous ways to do this, and a lot of people have opinions. In general, the conventional wisdom is don't do it. Don't download the file using Selenium. But there are 3 different ways to go about it, and it's worth mentioning them just so you're aware of what they are. So there are 2 different approaches. So within Selenium, you can configure Selenium so it downloads the file locally to the disk and then delete the file when you're done. Or you could actually use an HTTP library and then perform a head request on that file, and then check the headers to make sure that you got the correct content type, the correct length. Make sure that the file is empty, basically. And the reason why you might want to do the latter is it's an order of magnitude faster than using Selenium. It also doesn't require you to download anything if you're using an HTTP library. And so just to show you real quickly what it looks like using Selenium to do this, you have to configure a profile for the browser. And the real rub of this is that there's not really a lot of consistency within each browser with configuring profiles to make it consistently download files the same way. So doing it one way in Firefox does not make it work the same way in Chrome, and it's actually very challenging to do this in Internet Explorer. So basically, here's what it looks like to do this in Firefox. And then this comment in that section is what it looks like in Chrome. And basically, what we have to do is download the file locally, and then we have to inspect the file, and then remove it when we're done. And so a bit of tap dancing going on here, but we get to the download page, we click a download link, and then we grab the file, and then we make sure that the file isn't empty, and then, of course, have to to make sure that we got a correct sorted file, make sure we got a recent file, and then afterwards it gets deleted. It's a lot of heavy lifting for something that can be done a lot more simply with an HTTP library, which looks like this. And what you see is what you get here. This is it, just this one page. We're using REST client just like before. The difference here is, so we get the page, and then we grab a link, and instead of clicking it, we're actually just going to perform a header request with REST client, and then inspect the headers. And in this case, we're expecting it to be a PDF file and not to be empty. And when it runs very quickly. If you are dealing with secure files, though, there's a bit more emphasis you're going to want to place on this. You're going to want to actually pull the session cookie out of the Selenium session and then pass it into the REST client library, which we're doing in this fourth line here where it says response REST client head. At the end here in the hash, it's actually, we're specifying the cookie name and passing in the cookie value that we pulled out of Selenium. And within Selenium, there's a command called manage, and then within that there is a cookie named. We can do a lookup basically, cookie names, and in the internet it's a rack application, and so it's rack.session to get this session cookie. And then once we do that, we have access to secure files. So if they're behind some sort of authentication, we can get access to them with an HTTP library. And if it's something more than like a different MIME type than an application PDF, we can do something like this, where we can actually just have a conditional check in a method that says if the file is a .jpeg, here is what the MIME type should be, or PDF, here's what it should be. And if we get to a point where we don't know it, then we want to raise an exception, basically. And then at that point, it ends up becoming more reliable, so we can handle more different file types. So that's the recommended approach for doing file downloads. And the last thing I want to cover is adding additional output to your tests. So there's a general rule of thought around screenshots and videos and that kind of stuff. This is a slightly more unconventional take. It's a helpful way to get more debugging information basically out of your test. So if you are doing screenshots and you are doing video, that you actually can learn quite a bit more quickly about your test. So highlighting elements is an interesting one to me. And what I mean by highlighting elements is this. You basically can take you could take the original style of an element and hold on to it, and then modify it so that you're highlighting it. So in this case, like I want to maybe highlight a dashed border around this specific element. So if a test is running, I can see like, oh, I clicked on this button, and as I clicked on it, it could actually create a border around it. And so basically, as I step through different actions, I can highlight different things. And then I can revert that element style later. So basically, as I step through my test, I can put a border around something or highlight it yellow, do my actions, and then revert it, and then keep going. And basically do that for all the actions if I wanted to. And here's an example of what that looks like. So using the highlight for finding a specific element. This is also helpful for making sure I know what my test is doing. So on this example of a large and deep DOM within the internet, say I want to find like a child sibling and make sure that I have the correct locator. This is one way to verify that. And this is what it looks like when it's highlighted. And then there's growl notifications. This is probably the most unconventional of them, but it's one of the more interesting ones. Because what you can do is you can add a listener when you create an instance of Selenium. And what that listener gives you access to, if you use the abstract event listener, is you get access to every single Selenium command as it's happening at different points of your test. And when you do that, you can use something like jQuery growl to pop up little notification messages of information about what's happening when it's happening. And so this is what the abstract event listener looks like in Ruby. But after we navigate to a URL, before we find an element, after we find it, before we click, after we click, we can grab information out and display that information to us in the test if we wanted to. If we actually make this so, for example, if we're running our test and the test fails and we want more debugging information, we could enable this kind of listener and then rerun it. and then we get all this information. The actual growl commands are something like this. If you're interested in the JavaScript and the nuts and bolts of it, it's basically we're checking to see if jQuery is loaded on the page. If it's not, then we add it, and then we go ahead and load jQuery growl, and then we make sure that it's included in the page. And then after that, it's just a matter of calling the growl command and passing in the Selenium information that we want from the abstract event listener. That's all the boring stuff, but here's what it looks like when it's done. So as the test is running, it's doing things, and as it's doing those things, it's displaying all the information that's happening in real time. So this is like really a treasure trove of debugging information, and if you wanted to couple this with the highlighting element that I just mentioned in the previous tip, that would be a really powerful 1-2 punch. And that's kind of the highlight I want to end you on. And as I mentioned before, if you're new to Selenium, check out the Selenium Bootcamp, a free getting started email course on how to get started with Selenium, and of course my book and my Selenium tip newsletter. And I guess now it's a good time to transition to questions, but before I do want to mention that the Selenium conference, the once-a-year annual Selenium conf, is happening in Portland, September 8th through 10th. And early bird tickets are on sale now, and they are going really quickly. They are almost sold out. So if you're interested in going to something like this, then please do check it out. And also, if you're interested in submitting a talk, we're always looking for talks for the program committee. So please check out the conference website and submit a talk if you're interested. And I want to thank Sauce Labs for sponsoring and SGA for hosting. Sauce Labs was gracious enough to offer a promo code if anyone's interested in trying out their service. Use this offer code Selenium Tips 2015 when signing up. And then if you want to get in touch, then please do. I'm available on Twitter at TourToDave. My email address is here, and then my website is on the bottom right, which has like links to my office hours that I hold every week, as well as like other things I'm working on. So please do feel free to get in touch.
All right, thanks, Dave. We'll now be taking some questions from the audience. There have been a bunch coming in throughout the presentation, so we'll try to get through as many as possible right now, but for those who are unable to answer live, we'll answer some of them offline. Okay, so Dave, this person has a question about PhantomJS. Can it emulate IE? He says, some of the sites I deal with are old Internet Explorer only third-party sites.
So PhantomJS it's rendering using WebKit, I believe, which is not the same rendering as IE, so it doesn't really get you that. It's more like, well, I guess it's technically not like any browser because each one's kind of evolved past that. But PhantomJS gives you kind of like a good enough cursory check to make sure JavaScript in general loads. But for older versions of IE, the only real way to get true testing is to use IE. Unfortunately, there's not really a good headless solution to kind of help you shortcut that. So that's where a solution like Sauce Labs is really better, because getting an old version of IE is very straightforward, and it's just a necessary evil. Plus, it's unfortunate because tests do run slower in IE, older versions specifically, especially if you're using, depending on the locators you're using. So unfortunately, no, you don't really get what you probably are looking for out of PhantomJS, not at that depth.
Okay, thanks. This person wants to know, is there a way to run RSpec Selenium tests in parallel? For example, if I set the target to a folder, it can run X number of tests simultaneously and give a single report for all of them.
Sure. Yeah. Yes. Absolutely. There's a library called Parallel Test, and that enables you to run your RSpec tests in parallel. You basically don't even have to specify the folder, but you could if you wanted to. Basically, you can have it consume all your tests and run them in parallel, and you can break them down to smaller subsets using tagging or specifying just a folder, and then it will run tests in parallel for however many threads you specify, and then however many threads your grid or cloud infrastructure can support. That's going to be the bottleneck. It's probably not going to be your machine running them in parallel that's going to be the issue.
Okay, thanks. And I'm afraid that's all we have time for, so that ends our event for today. I'd like to thank our speaker, Dave, for his time, and also Sauce Labs for sponsoring this web seminar. And a special thank you, of course, goes out to you, the audience, for spending the last hour with us. Have a great day, and we hope to see you at a future event.